Hi everyone, welcome to the 11th lecture of the data science series, which is logistic regression modeling. In this, we are going to cover two topics, which is how to perform logistic regression using Python and how to perform Poisson regression using Python. Now, what is logistic regression? It is a statistical method used for binary classification tasks where the outcome is categorical. It takes on two possible values. It models the relationship between a dependent variable and one or more independent variable by using a logistic function. The output is a probability score which can be mapped to a class label using a threshold. The logistic function ensures that the output of the regression is always between 0 and 1, making it suitable for predicting probabilities of binary outcomes. For example, logistic regression is used to predict whether a customer will buy a product or whether a patient has a disease or not, or whether an email is spam or not. Now for the code, let's start. First, we need to import the libraries. We'll use pandas for data handling, train test split for splitting our data into training and test sets, and logistic regression from xkline to build the model. Now, second, for loading the data. Next, we will load the data. Here, I am assuming you have a CSV file. Replace this with your dataset for demonstration. Let's say the target variable is target and the other columns are features. For this, see the line data is equal to pd dot read underscore CSV. We are reading the data. Then we are storing it in X and storing it in Y. Now, for splitting the data, now we'll split the data into training and testing sets. We'll use 80% of the data for training and remaining 20% for the testing. So as you can see, test size is equal to zero point 0.2 and random state is equal to 42. Now for training the model, now we'll create the logistic regression model and train it using the training data. Here you can see that we are creating log regression is equal to logistic regression bracket and logistic regression dot fit x train y train. Now for making prediction, fifth step is the once the model is trained, we can use it for making predictions on the test data. Y prediction is equal to logistic regression dot predict x text. Evaluating the model. Finally, let's evaluate the model's performance by calculating the accuracy and showing the confusion metrics. So, at last, we'll print the accuracy and confusion metrics. Now, the next topic is Poisson regression. Poisson regression is a type of regression model used when the dependent variable represents count data. This means the target variable takes non-negative integer values such as number of events occurring within a fixed period of time or space. Poisson regression assumes that the dependent variable follows a Poisson distribution, which is commonly used with count with an underlying rate. Now, let's see an example of code for Poisson regression. First, we are importing libraries, pandas, and stat model. Second, we are loading the data. Data is equal to pd.read CSV. We are reading a CSV file and storing it in X and Y. Now, adding the constant. X is equal to sm.add constant X. We are making a Poisson regression in stats model require us to add a constant to the feature set. We have to add a constant. So, X is our constant. Then fit the model. For this syntax is used as you can see Poisson model syntax. Now, fifth, for reviewing the result, we'll just print a Poisson model dot summary. Now, you may want to know what is the difference between logistic regression and Poisson regression. So, logistic regression is primary for binary classification problem, where the target variable is categorical. We have to give an answer in yes or no, or success or failure, just or true or false. But in Poisson regression, on the other hand, it is used for count data, where the target variable represents the number of occurrence of an event, often modeled as a rate or a frequency. So that's the main difference between them. Thank you.